So when we're subtracting polynomials, some of you are going to, eventually maybe you're going to be like, no, I can do this without doing it her way. That's cool. If you can get them right and you can do it without doing it my way, that's fine. But the majority of you just proved basically that, you know what, that subtraction and negative stuff is going to cause some trouble. So here's my way. I want you to write all subtraction as addition. So you're going to change all subtraction to add the opposite. But we are going to do it in steps. We're not going to get too carried away all at once. And then all we're going to do then is follow the steps we did yesterday for adding. Because once it's a straight addition problem, we should be able to do exactly what we did for today. So here's what we're always going to do first. We're going to look within the polynomials themselves. When we see this subtraction going on here, we're going to say, first of all, I'm going to change any subtraction within the polynomials to add the opposite. So does the first polynomial have subtraction? No. How about the second one? No. So we get to skip that. Now we're going to go to, we can drop the parentheses from the first one. And what allows us to drop the parentheses from the second one is by changing it to addition. And every part of the polynomial that's getting subtracted has to change to its opposite. So this will become plus a negative 3x squared. So the subtraction became addition. The only term of the polynomial that was being subtracted became its opposite. Now we're going to do exactly like we did yesterday. We're going to rearrange it so that we have like terms together, and we're going to do it from greatest degree to smallest degree. So the x squareds are greater degree monomials than the x. So they get to be first. The x brings up the rear. All we're doing in this step is rearranging just like yesterday. And now we will combine like terms. These guys are alike. What do they become? Negative 2x squared. This one doesn't have anything to be combined with, so we just bring them along. Is that in standard form? Yeah. It's got the x squareds first, the x to the first power following it, and they are not like terms we can't do anymore. Okay? That was easy enough, right? Now let's move on to number 2. Again, just stick with this, just give into it. First of all, change any subtraction within the polynomials, only within the parentheses, to add the opposite. So this one I'm going to change to 9y squared plus a negative 3y. That subtraction is going to stay. This one doesn't have any subtraction, so no reason to mess with it. Now I can ditch the parentheses in the first polynomial without doing a darn thing because we never change what's in the front of a subtraction problem. So we have 9y squared plus negative 3y. That just stays what it is. This subtraction sign becomes an addition. This time we have 2 terms in our polynomial being subtracted. Both of them have to change to their opposites. So plus a negative y squared plus a negative 7. Now go ahead and finish that because now it looks like yesterday's. And the final answer is we agree? Okay, I want you to do only the first step in number 3. What's going to help us set it up for success in number 3 before we deal with the in between. Don't mess with it right now. Do you agree with me? Check me out, because in the last class I did it wrong. So. Do it right. Only thing I want you to do is change the subtraction within the polynomials themselves, right? It's going to be our first step. Our second step then will be, now let's deal with the fact that we have that subtraction there. And remember, what starts out, that polynomial we're subtracting from, it does not change. But the polynomial that is being subtracted now becomes every piece of it. This time there's 3 terms. Every term has to change to its opposite. And if you keep them lined up right underneath, then it's pretty, when you're checking to make sure that's what you did, it makes it a little easier to see. The opposite of 5 is negative 5. The opposite of negative 5 is positive 5. And the opposite of negative 8 is positive 8. And now you're ready to rearrange and add.
Mr. Rossman to Mrs. Manlow's room, please.
Final answer is, Jennifer, you got it for me?
2m to the 4th plus 3m squared plus 8.
Do we agree? Okay. Now, I'm just going to down here on my white space, and you just, you can do it if you want to on the bottom of yours, or it's your call, but let's take that problem that we started class with that only 3 people got right. And let's apply what I just said will help you maybe be more successful. The problem started like this. 3 take away 6, subtract, negative 6, subtract 3. If we applied the same process to this that I've been talking about, what would we do first?
Switch the signs, subtract and switch everything to the right of that.
But not until, the only thing we should do in the first step is what? So we don't get too carried away too fast.
Add the opposite.
Add the opposite where? In the parentheses, yeah. We're just going to deal with it inside the parentheses. And we got to know where it means subtraction and where it means negative, right? This means subtraction. That means negative. Here's another subtraction. Okay, so we change our subtractions to add the opposite. Now we're ready to drop the parentheses and change the subtraction of the polynomials to add the opposite. So the opposite of negative 6 is? Opposite of negative 3 is?
6, 3.
And now we just have an addition problem. Addition allows us to add in whatever darn order we want, group whatever together we want. It is the friendliest operation around. Well, multiplication's kind of there too. I see these guys in the middle and I say, you know what relationship do they have? They're opposites, which make 0. And you add 0 to something, it's like, you know what? So these guys take care of each other, don't they? 3 plus 3 is 6. The correct answer. Okay. So I don't know where yours went wrong, but maybe applying this to it would have helped us get to the right one. Okay. Okay, let's go to the back side where we're going to do some word problems. Number 4, there are 2 boxes in a storage unit. The volume of the first box is 4x cubed plus 4x squared cubic units, because volume is three-dimensional. The volume of the second box is 6x squared minus, or 6x cubed minus 18x squared cubic units. Write a polynomial for the total volume. Write a polynomial for the total volume of the two boxes. As soon as I see that word total, what does that tell me I should do? Better add them together. Okay, so what do we need to add together? Well, we got this one's volume and this one's volume. We need to add them to each other. And whenever we set up polynomial anything, we need to show the polynomials with parentheses. This is the first polynomial volume, and we're going to add it to the second polynomial volume. And since it's addition, we're pros at that. Now go ahead and get the volume for these two boxes combined. The combined volume is what?
10x cubed minus 14x squared.
You said 10x cubed minus 14x squared. Is that what I heard?
Yeah.
You agree? Yeah. Okay. Oh, and then I bet some of you remember the last assessment and you lost some crazy points for what? Not labeling. Huh, I wonder what the label would be for this answer. Cubic units. It's volume plus volume. They were cubic units. When you add cubic units to cubic units, you still have cubic units, don't you? So when they say write a polynomial, this is the addition of the two polynomials. We're not done. We have to finish, and that would be our final answer here. Now let's say I play the lottery, even though I really don't, and I win, and I come back tomorrow and I say, you know what, I give you this polynomial addition, subtraction, whatever problem, and I say, I'm going to give each of you that get it right $100. What do you want to get right? And I spread you out all over the room so that you can't cheat. You can't use anybody else's brain. You have to use your own. And I, say, are you sure you want to hand it in? Are you ready to win this $100? And you're like, okay, so finally you hand it in. And then three people again just get it right, and the rest of you don't. What do you think you could do to better guarantee a good answer? How would you do a check problem for something like this? I agree, a check problem would be nice, because check your stuff out. How could you do a check problem though? Because we didn't really solve and get a nice value or anything. And you don't get to go check it out with another student in the class. You don't get to go check my answer key. So how could we check it out? So I'll take $100 from somebody. I would want to make sure I have it right. It is. No? I think I have one. This is what I would do. I would pick some random variable for x, like maybe 3, because I have 3 children. Yeah. I'd pick 3. I'd pick some random variable for x, and then I would substitute in to my original setup. I'm hoping I have a good setup to start with. That's all I can trust, is that I at least set it up to start with, right? And if I substitute 3 in for all the places where there are x's, and I get a value, so I do all my multiplying, order of operations, I do everything I need to do, and I get this nice value. And then I go put the 3 back down into its my answer, if I put 3 in for the x's in my answer, should I get the same value? If I did it right? Yeah. Yeah, so it might be worth, just might be worth checking out sometimes if it's a big deal to you. Okay, I want you to read through number 5. I want you to get set up on it. What would the setup be for number 5? If we don't start right, then for sure we're not going to get the right answer. Okay, by the way, don't worry about that x equals 2 right now. It's kind of like, don't even go there. Please share with me, Landon, what's your setup?
Parentheses 15x, parentheses plus parentheses 10x minus 2 parentheses.
Is that it?
Yep.
Okay. So you going to be successful in class? Yeah. Is that a good start? Really, you all think so, huh? Alicia?
What if you multiply by and addition?
Multiplied by the what?
Like multiply them together?
No, because when would we multiply them together? We're trying to find the area. So if we were trying to find the area, that'd be a great plan. We're trying to find perimeter. What is perimeter? Don't you need 2 of each? Distance around. So don't you need 2 lengths and 2 widths? So we can't stop there, can we? We need another 15x. We need another 10x minus 3. This is a 4-sided rectangular field that we need the distance around it. That's what perimeter is, distance around it. Okay, go ahead and figure out what's the perimeter in polynomial form. What's the perimeter of this field?
50x minus 6.
50 or 15?
50.
That's what I thought you said. 50x minus 6. Okay, you guys agree with math? Okay, I do too. And what would we give that one as a label? What were those measured in? Yards. Okay. So that's its polynomial perimeter. Now they say, oh, hey folks, what is it when x is 2? So right here, when x is 2. So when x equals 2, we are supposed to figure out what the perimeter is. So we just sub in, don't we? Why? We're not going to go up there and do it up there. That's a whole lot of work when we know that the perimeter is 50 times x and then subtract 6. So the perimeter is what? 94 yards. When x is equal to 2. Okay, why don't you try reading through the next one, see if you can make sense of that one. So we're supposed to find the width of the river, which on mine is the red, right? Okay. And then we know the distance from each cabin to the river. And then we know that from cabin to cabin across that river, we know how far that is. So any suggestions what we could do here? We gotta find the width of the river. Start anyway. Trevor?
Parentheses, I put 12x squared minus 7x plus 5.
Okay.
And then minus, parentheses, 9x plus 1. And then plus, in parentheses, 3x squared plus 4.
So plus and then another parenthesis.
Yeah.
So like this.
Yeah.
What do you think? Will this work? So take the total distance across the river from cabin to cabin, subtract the distance from one of the cabins to the river, but then add the distance from the other cabin to the river. I think we need to doctor this up a little bit. Anybody think you know what we should do instead? Just one little thing. Zach?
With addition similar, should that be subtraction?
Yeah, we need to subtract both of those blue distances, don't we? We have to take this blue distance out of that one. We have to take this blue distance out of that green, and then that should leave left over. So it's kind of like, here's what I see. I see that I would have a blue distance plus another blue distance, or no, red distance in there, and then plus that other blue distance, and that should equal the green distance, shouldn't it? So if I have the green distance, don't I have to take these two out of there? I have to take them away so that I can just have the red distance left? Yeah. Okay, well, what would be a good place to start then? Well, let's do what I say about parentheses and changing any subtraction within parentheses. Only take care of that. Well, there's only one to do. It seems like a whole lot of writing for that, doesn't it? There's only that one subtraction inside the parentheses. Okay, now we're going to start ditching the parentheses. We don't have to do anything to ditch the first set of parentheses because it starts the problem out. We're supposed to subtract 9x plus 1. So that would be the same as adding a negative 9x plus a negative 1. Both of those have to change to their opposites, right? And then from that, we're supposed to subtract. So now we're going to add. We're supposed to subtract that negative, or that 3x squared and that 4, so they both have to change to their opposites. I think we got it. Okay, let's go give it a try and see what we end up with. Don't leave anybody out. I forgot to carry all mine. And the final answer is 9x squared minus 16x, is that what I heard? No constant? What happens with the constants? They cancel. 5 plus actually right here we can see that's a negative 5, isn't it? And negative 5 plus 5 is 0, and so we end up with not a perimeter this time, a distance across the river. What label would this get? Feet. Okay, I don't think we're done though. Because you know these darn word problems, Joe's gonna go back and make sure they don't want anything else from you. Then calculate the width if x is 3. So we're going to get the width when x equals 3. So that means put 3 in everywhere you see an x in that polynomial. I'm going to change it to add the opposite here. Okay, some of us like to rewrite the rules. Order of operations says do what first? The exponents first, not the 9 times 3, but 3 times 3, which is 9, right? 3 squared. And then what's negative 16 times 3? Negative 48. 9 times 9? 81. 33. 33 what? Feet. Okay. So you have 11 problems to do today for tomorrow instead of 16. But I'm going to guess some of them are going to be word problems like this. Make sure you do everything they ask you to do. Anybody